what's about. So it's about how to automate CI/CD in machine learning using Kubeflow pipelines. And I'm going to be talking primarily around the automation bit, the CI/CD bit, and the Kubeflow pipelines bit. The assumption being that you can apply this to any type of machine learning problem. So we're not going to be talking about the machine learning aspect of it, but we're going to be talking about everything that surrounds it. And much of this talk is essentially going to be a demo. You're all going to get these slides in a few days, but if you want to like capture this QR code, everything that I'm going to be talking about is on GitHub. It's in this repository. And all of the stuff that I'm going to be talking about, those are the instructions, starting up with how to set things up and how to go ahead and do everything. So I'm just going to walk you through all of the pieces and why we're doing what we're doing. But this is primarily demo driven, and I know that something that's very demo driven, it can be hard to kind of follow along exactly where am I, what I'm doing. So this provides the structure if you want to go back and look at it later on what's actually happening. So the whole story here starts with, people have been doing machine learning for a few years now, but one part of ML remains very hard. It's relatively easy to develop a model, right? So I was talking to someone earlier just before the session, and he was asking, why is everyone talking about ML ops? And then I come to an AI conference and no one's actually talking machine learning. And the answer is that these days, if you want to do image classification, you just go use ResNet 50, and it's essentially no different than using a sort algorithm. You don't really care how the sort algorithm is implemented. It's an API and you're going to call it. And for in a large number of cases, that's the way that most of us do machine learning, right? We go get a Colab notebook somewhere, and that has all of the steps, and we're going to run it, we're going to plug in our data, and we might basically look at graphs slightly differently. But the machine learning itself is relatively well understood, and it's a reusable problem, and we're basically solving it. But then the next problem comes, I'm going to take this thing, and I want to basically deploy it in production, and that part is hard. Again, Gina is an O'Reilly vice president, and she's talking about like it took 3 weeks to develop the model, but then deployment is basically a problem. So how do we go about taking a machine learning problem that we know how to solve, and how do we basically take this thing to production? And it all starts with having an environment in which you can basically carry out machine learning in a repeated way. The idea being the way you develop should be the way you deploy. And if you can do that in a consistent environment, it basically allows you to capture the steps that you're doing during development and making sure that you don't forget the steps, right? The worst thing that you can do is that you can say, I'm going to develop in a notebook, and then I'm going to basically take everything that I've done, I'm going to recode everything in Java because my production system is in Java. That's a recipe for disaster, right? So you basically want to think about how you do it in a repeatable way. And on Google Cloud, the way you can do this is through Kubeflow pipelines. So essentially, we go to we can go to the first link on here, and I can say, okay, let me go ahead and go to the Google Cloud platform. And there we are on the Kubeflow pipelines. And I can say, okay, let me go ahead and configure it. And again, Kubeflow pipelines is so I need to go ahead and select my project. Let's go ahead and do that. And go ahead and give this cluster a name, okay? But let's just go with that if necessary. And say, okay, I want to go ahead and I want to deploy this cluster. And I've already done this. So I'm going to do a little bit of the Julia Child stuff here. I can do that thing, but I already have it set up. So I'll just go to the thing that's already set up. So here is my pipeline. It takes about 2 to 3 minutes to start. The pipeline is started, and I basically get something to open up a dashboard. And I can then go ahead and say, okay, now I'm on my dashboard. So this is now a Kubernetes engine that's running on Google Cloud, and it has all of the software necessary to manage ML pipelines. Right? So it was basically that one-click thing to go and deploy it, and it has a few example pipelines, but because of the pipeline cluster that I've had running for a while, it also captures all the runs that I have done so far, and you get to see the warts and all, right? So successful runs, unsuccessful runs, you can go ahead and look at one of those successful runs and say what's happened there. In this case, it was like 2 steps. I've done some training and done a deployment, and I can go ahead and look at these things. I can look at the logs for it, etc., etc. Right? So this is a way in which I can go ahead and capture what's actually happened in those steps of my entire experiment history as I went through developing and deploying these things. So what I'm going to talk about now is how that thing is set up. What does this train and deploy? What was those boxes? How do we write them? Where does that fit into our machine learning models that we are writing? How do we capture the repetition? And more importantly, how do we make it such that it is continuous integration? And how do we make it such that it's continuous deployment? So basically what I have here is a Google Cloud Kubernetes engine cluster, right, that can execute ML pipelines. It's a long-lived cluster, so the idea is that your team, everyone uses the same cluster, and into that cluster you can submit a pipeline, right? So I can go to this cluster and I can say, all right, where's my dashboard? I can go ahead and I can go to the pipelines, I can upload a pipeline, but I will also have a Python API to which I can use to submit from my notebook. So I'll have a Jupyter notebook. So here's going to be my Jupyter notebook. And let me go ahead and reload it. So that's my Jupyter notebook that's running. It's not on the cluster, it's somewhere else. And having gotten that notebook up, I can go down to my notebook, and the key thing here is that it needs to be able to connect to that pipeline host. And the reason I know that that's a pipeline host is that I can go look at the settings and it tells me what the pipeline host is. Right? So as long as I know the host URL from any notebook, anywhere that I have permissions to it, I can essentially go ahead and create a Kubeflow client, and I can use that Kubeflow client to run a train and deploy function. So that was a function that you saw, and in my Python file, I have a train and deploy function that basically says, please go ahead and create a container operation that does the training of tuning, and that comes out of the container registry, and go ahead and do a deployment operation that also comes out of the container registry. So there are 2 containers that I have in the container registry, and I'm basically saying run the first one, and the first one is basically going to take all of its output and throw it into this place, right? And the second container is going to use the output of the first container, right? So the first one is going to do the train, is going to write out a model, and then that model is going to get deployed. Okay, so it's a very simple 2-step pipeline that I have done. But then there's also a more complex pipeline that involves everything from pre-processing and hyperparameter tuning, and then drops down to the training and deployment, the 2 smaller steps, and also a web front end at the end of it. So again, it does not really matter what these steps are, but the idea is that each of these steps is a container that I'm deploying to a Kubernetes engine. And the idea is that we don't really need to know about Kubernetes. Kubernetes is like, below the scenes. What we need to know about is how to build those containers, because it's those containers that we're linking together and we're submitting as a pipeline. So the thing that we need to talk about is that what is this pipeline? This pipeline is a directed acyclic graph, so you can have circular dependencies. But as long as that's the case, then that pipeline consists of a bunch of different steps, each of which is a container, and the output of one container basically feeds into the inputs of subsequent different containers. And each of these pipelines, we can then group them into experiments. So you can say, here's an experiment, and I'm going to run a certain set of pipelines, right, at different times, different ways, and I'm basically grouping the runs. So you can think of an experiment as like a project, right? So you're basically doing the same kind of thing over and over again. So it allows you to group so that you don't just, because remember that you'll have a team and everyone's going to be submitting a bunch of different runs. So you want to have some way of grouping these together, and that's the experiment part. It's a way to group a set of runs together. So ultimately then, what we're essentially talking about is machine learning pipelines where every step is a container. So we're talking about containerized pipelines, and all that Kubeflow pipelines is an environment in which we can submit these steps that we want to do. So how do we develop these things? So we develop these pipelines in a notebook, right? That's the traditional environment that we all develop machine learning models in. So it's the exact same development environment that we do it in. But because we're going to be submitting to a cluster, it's usually a good idea to use not your personal credentials, but the credentials of a robot account, a service account. Okay, and that service account, it basically it will execute on your behalf on the cluster. So in this case, again, and the GitHub repo walks you through the steps, you will create a service account and you will use that service account whenever you're basically submitting jobs into the cluster from the notebook. And this service account, now you have to look at your pipeline and say, what is this pipeline doing? And in my case, my pipeline is going to be reading data from BigQuery. It's going to be basically doing some things with Cloud SQL. It's going to be doing data processing with Dataflow. It's going to be doing deployment into ML engine. It might at some point read from PubSub. So I give all of those permissions and say, these are the things that my pipeline needs to be able to do. And having done that, then we're now ready to start writing our code. And in our code, so now let's just walk through what the code looks like. So here we are. So here's my containers. And the first step of my ML pipeline, so my bigger pipeline, pre-process, train, and deploy, the first one is a pre-process step. And it needs a container called BigQuery to CSV. Right? It's basically exporting data from a data warehouse into CSV, and it's doing some pre-processing along the way. So that is this container. So I've just organized my project such that each of the steps in my ML pipeline is a different directory, and each of these is going to basically end up creating a container at the end of it. So let's go look at the BigQuery to CSV. So this is basically what it contains. It contains a transform.py, which is the actual Python code that's going to do the transformation. It's going to read from BigQuery, it's going to do some pre-processing, it's going to do some data munging, and it's going to write out a CSV file that's going to get used for subsequent training. And then I basically have a Docker file that basically says this is how you create the container. So let's go ahead and look at transform.py just to say that there's no magic here. This is just the normal standard kind of thing. If you're used to doing pre-processing in pandas, the pandas code would go in here. In this case, I'm doing my pre-processing in Dataflow, right? So I'm using Apache Beam. So that's basically the Python library that I'm importing. I'm importing Apache Beam. And in this case, the problem is of predicting the weight of a newborn baby. So we're basically going ahead and reading all of the data, and we're doing some data munging. The details don't matter, but what it's essentially doing is that there's a function called preprocess that starts off by doing a select query from my data warehouse, and having done that, it basically goes ahead and applies this function to manipulate the data and then writes it out into CSV files onto Google Cloud Storage. So that's the basic pre-processing step. And this thing, I can run from a notebook, right? I can basically try it out, and when I'm done with that, I basically have to package it up as a container, and that's where the Docker file comes in. And that's pretty much it, right? Basically, because I'm using Dataflow, there is an ML pipeline container from the Kubeflow Pipelines project that allows us to say, okay, here's a container that has all of the dependencies for Dataflow all packaged in. So I'm basically subclassing from that. And I'm basically saying, please copy my transform.py into that image. And the entry point for this container is to run transform.py. That's pretty much it. Okay? So once I have that, I can then go into here, into my bq.csv. Pipelines, containers. All right, so I have my BigQuery.csv, and the code I'm going to run is to build a container. Okay, so what this is essentially doing is that it's using a Google Cloud command called gcloud build, right? So that's basically called cloud build, and it's a serverless way by which I can just submit my Docker file and say, go do the build for me and push it into container registry. Okay. So that's basically what's going to happen here. I'm going to say, please go ahead and build the container for me. And it's basically going ahead and creating this tarball of my directory and submitting it to cloud build. And this entire Docker container is getting built and it's getting stored in gcr.io. Okay, so this is your normal stuff, but the cool bit is that I'm not actually building it on my Jupyter image, right? It's actually a serverless service, right? I'm just submitting it, saying, go build it for me, push it into gcr.io, and I'm done. And so that's the thing that now, when you go and look in here, that's where this particular container comes from. So I just have to do this manually for every one of my directories while I'm doing my development. But what does CI mean? It means that every time I check in the code, every time I change transform.py, I want this container built. Does that make sense? So now if I check in, so what files should I look out for if I want to do continuous integration? Just the Docker file, transform.py. If either of those changes, I just need to rebuild and put a new container in there. And then the next time the pipeline runs, it's basically going to pick up this new container. That's pretty much it. Right? The key thing is to organize your code in such a way that every step is a different folder. That way you're not building the entire pipeline whenever any of these pieces of code change. You're only building that one step of your container. Fair enough? So let's walk through how that part works. So basically I wrote, right, each step is a container. I wrote the code for that container, and then I basically tied them together with that pipeline function, pre-process, train, and deploy, right, where that was the first step, the hyper trained is the second step, and so on. So I have a container for each of my steps, and that Python function captures the pipeline. That's the thing I'm going to submit and say, run this pipeline. And it's going to pull each of these containers. That's going to happen on the Kubernetes engine. So it's going to do all of the auto scaling, all of that magic is going to happen for me, right? By default, if there are GPUs on those things, those are all going to get going to get used, and I don't have to worry about it. All I have to do is to write code. It's pretty cool. So once I write my pipeline, I have to submit it to the cluster. And the way I do that is that I can basically say client run from pipeline function, and basically passing in the train and deploy, a pre-process train and deploy, and any kind of adaptable parameters, and that's the args. Okay. So I could do it the graphical way by going and clicking on upload pipeline function, but that gets old very quickly. Right? So instead, you basically put the 2 lines of code in your Jupyter notebook, and you run the cell every time you want to run the pipeline. And once you run the thing, you can go and look at the code, and you can basically see that it's executing and what it's doing, and look at the logs, debug, do all of the stuff that you normally do. Fair enough? Now, I'm showing you as if you have to build containers from scratch, and that's not the case. Right? There is higher level abstractions that have been built. Right? So you have these very lightweight Python components. So you have the ability in Kubeflow pipelines to basically write a Python function and say, make a container out of this function. And it will go capture all the dependencies and do that. Usually those images tend to be bigger than something like this, where I know I'm using Dataflow, I can basically just go to the Dataflow image and do it. But that also is captured, where you basically have on AI Hub, you basically have a lot of these pre-built components that you can take and you can basically subclass from. And final thing is that instead of doing these one step at a time, you can have a prescriptive approach, that's TFX, where each of these is a container that's all published, and you can basically say into this container, this is the part that I'm configuring. But ultimately, they all land up as containers. So whenever any of the pieces of code that you have need to change, you need to make sure that the container is rebuilt, right? And that's where the continuous integration comes in. So continuous integration essentially means whenever some piece of code changes, rebuild the piece of code. So for continuous integration, what I'm going to do is that I'm going to set up a GitHub action, right? And I'm going to say that first of all, I'm going to connect my Google Cloud project to GitHub. And that the way you do that is that you have a way to basically connect up your repository. So that's, again, just a one-click thing. You have to connect repository, select your source, which is on GitHub, and then you basically say, all right, I'm going to give the authorization. And at that point, we can now write code that looks like this. So this is a bash script. I'm creating a GitHub trigger where I'm saying gcloud build, right? This is the same command I used to build the container manually. But in this case, I'm basically setting it up to be a GitHub trigger. I'm saying create a GitHub trigger where I'm going to use the cloud build.yaml. This cloud build.yaml got created for me when I built the container image the first time, right? Out of the Docker, when I took the Docker file and when I'm developing, I'm going to basically do gcloud build s. The very first time is going to go create a build.yaml. I'm going to just go ahead and use that. I'm saying included files in repo, everything from this location downward. Right? So all of these files go in, and whenever I commit into master, please go ahead and trigger this new build. And I go ahead and do this for all of these subdirectories. So I just run this once, and the GitHub triggers are created. Now every time I do a GitHub commit, it's going to basically change. Fair enough? Yeah. So maybe we can try that. Actually, this is just minor stuff. I don't want to pollute the GitHub repository by making a commit, but trust me, it works. Okay? So you do a commit, and it basically, this thing takes care of it, right? It takes care of going and rebuilding the container image, and the image is there. So now, we know how to update the image, and the next time the pipeline runs, it's going to basically pick up the new image. Okay. What does continuous deployment mean in machine learning? Now, this is where it gets slightly different. When you talk to a CI/CD in terms of traditional software development, the idea is every time the image changes, you redeploy the application. It's a web app. Your code is changed. You rebuild it, and you redeploy it. They go together, right? It's not like you're going to build it, and not deploy it. Well, what might change is that you might deploy to a staging area and might do an A/B test before you move it over. You might do things like that. But typically, you always deploy every time your code changes. That's not the case here. Typically, you might want to distinguish between CI and CD with the sense that there's other reasons to do deployment. What other reasons? Besides a code change, why else might you want to redeploy? What does deploy mean in machine learning? In this case, it's deploying the entire pipeline, right? And the pipeline, remember, what does it do? It does training, it does evaluation, it does deployment, right? It does hyperparameter tuning. When might any of these things, when might you have to redo them?
You have more data.
When model drift, right? If there's new data, if the business environment has changed. So those are the events that you're going to be looking for. So in this case, I'll just take one example, right? And I'm going to basically say, okay, for continuous deployment, I'm going to look for new data. Whenever a new data file shows up, I'm going to basically relaunch the pipeline. Fair enough? And so that I'll do using Cloud Functions. So again, serverless. And the idea is that every time I get new data, I'm going to retrain the model. So my Cloud Function is going to be, there's going to be a function called handle new file. And it's basically going to call my pipeline function, fine tune and deploy this thing, given the file name. So what it's going to do is going to take that original model, and it's going to run a few more iterations of training on that model. So it's not going to train from scratch. It could just go ahead and use that to do a few more steps, right? So this is a fine tune. The point being, we kind of choose how we react to events, and this is where you want to think carefully about the problem that you're solving, and do you need to train from scratch? Do you need to do fine tuning? Do you need to redo your hyperparameter tuning? It depends on whether it's model drift that you care about, whether it's new data that you need to refresh your model with, etc. But regardless, you write your function, okay? And the fine tune and deploy function is just a pipeline, right? It's basically saying, go ahead and do kfp.client with a pipeline host, and client, please go ahead and do train and deploy, right? And run those two container steps every time a new file comes along. So in this case, I'm not running the entire pipeline, I'm just running a small part of the pipeline. And that's the benefit here of basically saying, here's the event that I'm listening for, and this is what I'm going to be doing. And then once you write that code, and now here I'm just saying, I'm just deploying a cloud function, saying this is the Python 3.7 runtime, and it's basically going to go ahead and run this pipeline, starting from an intermediate step. So this is where it gets tricky. How do I start a pipeline from an intermediate step? I need all the outputs of all the previous steps, right? In order to start from an intermediate step. In my case, what I'm doing is in my pipeline code, I can do something as straightforward as when I'm starting at an intermediate step, I'm storing, right, the output of the previous steps. Okay. So I'm saying when you run the pre-processing, all the pre-processed data is in this bucket. So just go read that bucket. Okay, and then of course it doesn't need to be hard-coded, and I'm showing you how you cannot hard-code it. In the second way, I'm setting an environment variable. And I'm saying, oh, the hyperparameter job is this job, go read that environment variable. So which means, then when I submit the, when I deploy the function, I can basically go ahead and set that environment variable. So this is the place where you read the output of that previous thing that's done from. So it could be hard-coded, it could be from an environment variable that's done in, you could obviously go read from a file, and it could be more dynamic, however you need to do it, right? This is not that it's, so this is just showing you some of these options that are possible. Cool. So let's try this. Okay, so this one's kind of interesting. So we can go, let's go back to our Jupyter lab, and I need to get new data. So what I'll do is I'll fake new data. Okay. So let's go to try cloud run.sh. So in this, so what I'm doing is basically I need to get new data. So here, I'm basically taking existing data that I have and just copying it over to the same directory. So that's a new file now, right? So this is going to trigger the cloud function. The cloud function is going to trigger a new a new training run. Fair enough? So let's see if the demo gods are with us. Okay, so try cloud function.sh. Okay, so it's now creating a new file. It copied the file over. And now what we can do is that we can go ahead and make sure that this cloud function actually ran. So go to the console. So now that the new file has shown up, we should see in our cloud functions a new run of the cloud function. So let's go down, there's the cloud functions. So I have a cloud function called handle new file, that's the one that I deployed. So let's go to the cloud functions, cross our fingers, okay. And let's see, there's a trigger, okay. And where's this? Let's see, where's general? Okay. So it was, okay. There's the last 7 days. And then let's go look at whether the final, let's just look at the final output. Let's see where the experiments are. all runs. And 10:01 a.m. Right? So the pipeline just got launched. Okay, something happened. It didn't run fully, right? But you saw that the trigger happened and the pipeline got launched. So let's go see why the pipeline didn't run. Train tuned, logs. Okay. So access denied, insufficient permission. Okay. So I changed something there. So, but the point here was that, right? New file showed up, right? Cloud Function created a new pipeline. The pipeline got submitted, right? That you basically saw the entire CD process happening. So, okay. So once I've done this, right? At this point, then I could have just stopped with the Cloud Function, but what I decided to do was to containerize the whole thing. Right? In this case, I have the handle new file. It's just a function. It's just floating around. I don't really want that. I want that to also be a component that I can do. So instead, what I did was that I took this handle new file code, right, and the pipeline launching and put it into its own build Docker file. And rather than launching it with a Cloud Function, I launch it with what's called Cloud Run, which allows me to run a container in a serverless way. Okay? So that way, the entire pipeline code is now completely containerized, and I can take this and run it on any Kubeflow cluster that I want. So what's next, right? So we basically look at how to do CI. It's as simple as going ahead and setting up a GitHub trigger and remembering to organize your code in such a way that every step is a different container. And then you saw how to do CD, which is to set up a Cloud Function or Cloud Run, to basically look for the kind of events that you care about and basically making sure that the pipeline gets launched. So what's next? Well, what's next is all of these things I kind of put together manually. It would be good if you had a Terraform script that basically connected everything together. The source code control, the CI/CD, the components in the container registry, the experimentation from the notebook, all of the metadata that we have, so that if the cluster goes down, the metadata is all still there, and all the old runs are still there. So store that in a database in Cloud SQL, and be able to run components like ML pipelines, and still be able to take advantage of all the serverless services like AI platform training and inference and so on. So what we want here, what I just did, kind of manually setting everything up and running all of those scripts, we want a Terraform way to kind of repeatably create this environment. And that exists. Okay, so go ahead and look at our cloud.google.com/solutions. We're in the process of building them and publishing them. So there's a GitHub repository with all of that Terraform stuff to set up the environment. The next kind of thing that's happening is what I showed you here was creating containers from scratch. And I kind of hinted at, look, there are ways that we're developing, ways to create a container from Python functions, ways to create containers from notebooks, but also ways to do reusable and shareable notebooks, right? So because we know that most ML pipelines consist of these steps, right? They're extracting data, validating data, preparing it, doing model training, doing model evaluation, looking at model explanations, right? So wouldn't it be nice if you actually had pre-built containers that did these things where you could just plug in your piece of code, right? And the rest of it was already there, and that's where TFX is coming from, right? It's TFX, a prescriptive pipeline with a whole bunch of pre-built things where you can just plug in parts of it. And so that's basically where we're headed, where a lot of these things like code repository, the artifacts, the way to store your models, the way to do serving infrastructure, everything that I linked up manually here, it's all basically becoming more and more automated and more turnkey. And another huge thing that's happening is it's not enough for you to write pipelines that are all independent of each other. There's this whole concept of a feature store where you're basically taking reusable parts of that pipeline and basically allowing them to be carried out. So, and all of the metadata and artifacts so that you can do continuous training. So takeaways here, right? Doing effective machine learning, it's not just the machine learning part. You want to basically think about creating your entire pipeline and how to basically set up CI/CD, continuous integration, and continuous deployment. And you can do all of this in a serverless way, right? So you should not be thinking in terms of having to set up machines and infrastructure and so on to do all of these things. It's just a question of writing code and submitting them to services. So the Terraform script is here, right? So if you look at our solutions, there's a solution called Continuous Delivery and Automation Pipeline, and that's where it is. And scroll down, and you will find the GitHub repository where all of that stuff is getting developed. And leave me feedback and shameless plug, right? So a couple of books on doing machine learning and data analysis on Google Cloud. And I'll take questions. Yes.
Yeah. So you mentioned about the model registry, right?
Yes.
And is there support for example, if I want to create different pipelines or different types of models within one registry and then
absolutely. So the model registry is essentially a place for you to store and share models. And by model, we mean a pre-trained with the weights, with everything, so that someone can take it, they can do transfer learning on it, they can do fine-tuning on it, or they can deploy the model. Right? So it's a way to basically share model artifacts, regardless of what type of model it is. So it's not just limited to TensorFlow. Yes?
I just wanted to mention, I don't believe that the hosted pipelines are
GA, yes.
Yes. So coming very soon, and if you're really super keen to try it out, and by very soon I mean probably like within a week, we can get you whitelisted though if you're very, very keen to try them out.
So this is all hot off the press.
Yes.
So try it out next week. So it works for me. It may not.
Yeah.
It may not. Thank you for giving me honesty.
I expected someone who was trying to find it on that concept right now.
Yes, if you click on the GitHub link, it worked for me, but it may not really.
Do you have any recommendations for setting up hybrid pipelines, right? Most importantly, on the edge. I'm not talking about like IoT devices, right?
Yeah. So notice that this thing here works with Anthos, right? So it's a GKE cluster. You can do GKE on-prem. You can do Anthos, and so this thing will work anywhere you can run Kubernetes. So it totally works on Anthos. Yes.
So behind the scenes, what are the technologies that are used? Is it Jenkins or Factory?
I'm not actually using Jenkins, right? I'm basically just using GitHub triggers and using Kubernetes, and I'm using Cloud Build. So essentially, I'm using Docker, but that's pretty much it. Yes.
Yeah. I'm wondering like the more like traditional like ML workflow, as far as like going from EDA all the way to hyperparameter tuning and everything like that.
Right.
So if now we're like in a paradigm where I'm working knowing that my work is part of a broader pipeline, like how do you think conceptually or like a data scientist or ML engineer needs to think differently about their work?
Okay, so that's a great question, and this particular repository actually has a opinionated view about this, right? So it's exactly what we're talking about, like all of these steps that a data scientist would do: exploration, sampling, doing your training with Keras or with TensorFlow, pre-processing either directly or with TFX, training either with TensorFlow or with BigQuery ML or with Keras, deploying it, and capturing it all in a pipeline. Right? So I just showed you the last bit, the pipelines bit. But we do have this whole, it's a very opinionated workflow of how you do each of these steps independently, and at the end of every step, how do you capture it into something that becomes a pipeline. Yes?
So how do you coordinate each of those? So if one fails and you don't like it, the results of one of them is...
Right, so on the pipelines, there's a whole idea of a condition. So you can actually do a conditional check, and you can have each pipeline basically write into error states, or you can basically say, evaluation, write out the evaluation metric out, and if the evaluation metric is not, if the area under the ROC curve is not greater than 0.95, don't deploy it, right? So you can write those conditions as well in your pipeline steps. All right. Thank you all very much. Oh, last.